Welcome to MSR Math classes. Here in this video, you can find out exercise 9.3, problem number 6 onwards. Please refer the previous video for the first 5 problems. So the first problem, sixth problem here is form the differential equation of the family of circles touching the y-axis at origin. So we need to form a differential equation here. Okay. Of what? Of family of circles that are touching the y-axis at origin. So, isn't it replicating the same thing? You are going to find out differential equation of family of circles that are touching the y-axis at origin. I have given one of the circle. Family of circles means you can find out another circle of this kind, another circle of this kind. These are all circles are touching the y-axis at only origin, isn't it? And their centers will be different, right? So first, suppose if it A I have given the center as, here in this case, first for this circle, A as 1, if you consider, it is a unit circle. For the next one, suppose this for this one, A will be some 1.5 or 2 units you can take. For the next circle, it is A equal to 3 and so on. Okay. So family of circles we have, when we mention, the center is keep on changing. That's why I have written A comma 0 as the center of the circle, family of circles. Okay. And for this one, what is the radius? If I consider this circle, this radius will be whatever this A, the same units will be the radius, right? Similarly for this also, if it is 2 units, 2 comma 0 is the center, then the distance from origin to that the point will be center will be 2 comma 0 and so on. So in general, for all the family of circles, I am considering A comma 0 as the center of the circle. Okay. So in that case, what is the equation of the circle? So whenever we have a circle of having a center as A comma B and the radius as R, the equation of the circle will be x minus A whole square plus y minus B whole square equal to R square is the equation of the circle. So by using that, one can write down equation of the circle here. So equation of family of circles touching the y-axis at origin is x minus A whole square plus y minus 0 whole square is equal to the radius is also again R is A here, so which is A square. So let me simplify this because it is in the form of A minus B whole square. So A minus B whole square formula, if you apply x square minus 2ax plus A square equal to, plus y minus 0 is y square equal to A square. So both sides we have A square, let us cancel that. So finally we have x square minus 2ax plus y square equal to 0. So let us consider this one as 1. So in order to calculate a differential equation for this curve, we need to eliminate the arbitrary constant which is appearing over here. How many arbitrary constants are there? Only one arbitrary constant is there, right? So to eliminate one arbitrary constant, we have to differentiate the given curve only once. So that is what I am doing here, differentiating the given curve with respect to x, with given curve with respect to x on both sides. So first differentiation of x square is 2x, minus 2a is a fixed constant and x differentiation is 1 into 1 plus y square differentiation is 2y into y dash. Be careful here, y square is y square differentiation is 2y and inner function is y, so that y differentiation is y dash equal to 0. So now you can clearly see each and every term on the left hand side is having 2 as a common factor. So if you take that common and send to the right hand, 0 by 2 is equal to 0. So I have cancelled directly. Now minus a, if I send to the other side, positive a, and the left hand side we are left over with x plus y dash. So can you see the arbitrary constant I am able to write down in terms of x and y dash itself. Now this a you can substitute over here. Okay. So substitute this one in equation 1. So x square minus 2 into x plus y dash into x plus y square equal to 0. So further if I simplify, x square minus 2x into x square minus 2x into y dash plus y square equal to 0. Further one can simplify, x square minus 2x square is minus x square minus 2x y dash plus y square equal to 0. Therefore, either this one or x square plus 2x y dash plus y square equal to, minus y square equal to 0 is a required differential equation. Okay. Let's move to the next question. Form the differential equation of the family of parabolas having vertex at origin and axis along positive y-axis. So here again, we need to find a differential equation of family of parabolas. So one of the parabola I have drawn, you can find out, you can draw the similar kind of parabolas whose vertex are touching the x-axis. And the axis is given along the positive y-axis. Okay. And since the foci is, since it is symmetric about y-axis, or the axis is along the y-axis, the foci will be lies on the y-axis. Let us consider this point as 0, a. So in that case, what is the standard equation of the parabola? So whenever a parabola is along, axis is along the positive y-axis, the equation is x square equal to 4ay. When it is axis is along x-axis, it is y square equal to 4ax. Okay. So the variables will be interchanged with, depending on the axis of the parabola. Yeah, by the way, here we have x square equal to 4ay. Since again here also family of parabolas. Whenever it is fixed parabola, then a will be fixed. But here the family of parabolas are given. That means the foci is not fixed here in this case. So family of equation of parabolas having vertex at origin and axis along positive y-axis. So we have to be very careful here in this case. Positive y-axis it is mentioned. So it is in this direction. Otherwise it will be inverted parabola. Okay. So that equation is x square equal to 4a. How many arbitrary constants are there? Only one. Right? So let us consider the equation as 1 and do the differentiation, differentiating with respect to x on both sides only once. So first differentiation, x square differentiation is 2x equal to 4a is a constant, y differentiation is y dash. Further, if I simplify both sides, we have a common factor as 2. If I cancel that, we will get x equal to 2a y dash. Okay. So can I write down this a as x upon 2y dash? Yes. Because we are trying to eliminate, in order to find out the differential equation, we have to eliminate the arbitrary constant. That arbitrary constant I am going to substitute in equation 1. So x square equal to 4 into a. A here is x by 2y dash into y. So if I cancel this one, 2 2s are x square equal to 2xy by y dash, or x square y dash minus 2xy equal to 0, or still x is a common factor here. So xy dash minus 2y equal to 0 is the differential equation for the given family of parabolas. Okay. Let's move on to the next question. Problem number 8. Form the differential equation of the family of ellipses having foci on y-axis and center at origin. So isn't it looks the same way, the pattern, the ellipses that are the foci on y-axis here, okay? That means the major axis is y-axis and the minor axis is x-axis. In such cases, what is the equation of the family of ellipses? So here in this case, the equation of the ellipse will be x square by b square plus y square by a square equal to 1. Okay. So where here it is 0, the y-axis, any point on y-axis is of the form 0 comma a, right? And on the y-axis 0 comma b comma 0, right? So equation of family of ellipses having foci on y-axis. Foci on y-axis it is mentioned, so the vertex will be over here at the end points, right? So here also this vertex will be 0 comma a and this is 0 comma minus a. Similarly, this is b comma 0 and this is 0 comma minus b comma 0. So in that case, what is the equation of the ellipse? That is x square by p square plus y square by a square equal to 1. Let us consider this one as equation 1. For this family of curves, we need to find out the differential equation. In order to calculate the differential equation, we need to observe how many arbitrary constants are present. That is the first step. So there are 2 arbitrary constants. We need to eliminate the 2 arbitrary constants by differentiating 2 times the given function, given curve. Okay. So first differentiating on both sides with respect to x. So x square differentiation is 2x by b square plus y square differentiation is 2y into y dash by a square equal to 0. One constant differentiation is 0. So 2 is a common factor, we can cancel that out. So this is my first time when we do the differentiation. Again differentiate one more time, differentiating with respect to x. Let us consider this one as 2 first. Yeah. Next do the differentiation. 1 upon b square plus 1 upon a square into, here y into y dash is there. There are 2 functions. Product rule we have to apply. So y as it is. Y dash differentiation is y double dash plus y dash into y differentiation is y dash. Right? So this is what we will get. So therefore 1 by b square is equal to what? Minus 1 upon a square into y double dash. Y dash into y dash is y dash is square. So don't confuse here. This entire term is multiplied by 1 by a square. That positive term is alone minus. This won't be changed. Okay. This will be positive only. Otherwise, if you can multiply first and then take minus 1 by a square is also works out. Yes. By the way, here 1 by b square we got it. This 1 by b square, in place of this 1 by b square, x by b square is there na? I can write it as x into 1 by b square. In 1 by b square, I can replace this one. So substitute this one in equation 2. So x into minus 1 by a square into y double dash plus y dash square plus 1 by a square into this is y dash equal to 0. So can you see here, both the cases the denominator is a square is there. So 1 by a square if I take common, x into minus 1 into this one. So minus x into y double dash plus y dash square plus 1. Yes, by the way, here we can take 1 by a square as a common, no? So I can write it directly plus y dash equal to 0. Now this a square sent to the right hand side, which will give us minus x into y double dash plus y dash square plus y dash is equal to 0. So can you see here? It is free from the arbitrary constants. So therefore, this is the differential equation. Hence, I can write down this one as further if I simplify x y double dash plus x y dash square minus y dash is equal to 0. I have sent all these terms to the right hand side, or minus take common, you will get a differential equation. That is the required differential equation. Let's move to the further question. Question number 9. Form the differential equation of the family of hyperbolas having foci on x-axis and center at origin. So can you see, this is only the parabola, this the hyperbola. These are all things you have studied in class 11. Right? This is a standard hyperbola whose center is at origin and foci is on x-axis. So a comma 0 and minus a comma 0 are the foci. Okay. So for this one, what is a family of equation of family of hyperbolas? Equation of family of hyperbolas having foci on x-axis and center at origin is x square by a square minus y square by b square equal to 1. Again, how many arbitrary constants are there? There are two arbitrary constants. So we have to differentiate it two times. So first time differentiating with respect to x. X square differentiation is 2x by a square minus 2y dash by b square equal to 0. Now 2 will be cancelled out. X by a square minus y dash by b square equal to 0. Let us consider this one as 2. Again differentiate one more time with respect to x. X by a square, x differentiation is 1 upon a square minus 1 by b square is a constant. Y dash differentiation u into v. So u v dash means y into y double dash plus u dash v. Y dash will be as it is, y differentiation is y dash. So y dash into y dash equal to 0. So can you see 1 by a square, I will get it here in this case as 1 by b square into y double dash plus y dash square. Same like the last problem. This one I am going to substitute in equation 2. So x into 1 by b square into y double dash plus y dash square minus y dash by b square equal to 0. Again, same case, LCM, I mean both the terms are having b square as common, or LCM if you take b square will be cancelled out. So the remaining whatever we will get, that will be the required differential equation. So x y double dash plus x y dash square minus y dash equal to 0 is the required differential equation. The 10th question. Form the differential equation of the family of circles having center on y-axis and radius is 3 units. So the first sixth problem, I guess, like what we have done is center on y-axis and it is touching the y-axis at the origin, it is mentioned. Yeah, not center on y-axis. So family of circles touching the y-axis at origin, right? But here the family of circles having centers on y-axis and it is having the radius is 3 units, it is mentioned. We don't know where it is. It is not touching, it is not mentioned anything. It is whether it is touching the y-axis, touching the origin or not, that is not mentioned. Only mentioned that the centers lying on y-axis. Okay. So 0 comma a. So as I can change a value, I can get different kind of family of circles that are having centers on y-axis. Okay. Of course, this radius is it is mentioned it as 3 units. So here to here it is 3 units. So in that case, what is the equation of family of circles? So let us write down first of all that equation of the family of circles having center on y-axis and radius r is equal to 3 is x minus 0 whole square, a comma b, when we consider this is 0, plus y minus b here is a. So y minus a whole square equal to, the radius is given 3 square. So if I simplify this, x square plus y square minus 2ay plus a square equal to 9. Right? So how many arbitrary constants are there? There's only one and only one arbitrary constant, that is a is present here. Yeah, I can, otherwise I'll write it as it is, only this much only. Why is it so? You will understand here. Because y minus a whole square, anyways a won't be simplified here. So I'll write it as it is. You will understand why am I writing like this at the end. So let me consider it as equation 1. Now we are going to doing the differentiation with respect to x on both sides. So x square differentiation is 2x. Y minus a whole square differentiation is 2 into y minus a. And inner function is y dash minus a minus 0. So just y dash equal to 0. So 2 is a common factor, cancel it out. So y minus a into y dash is equal to minus x, and y minus a is equal to minus x by y dash. Okay. So can you see here y minus a arbitrary constant is present over here on the left hand side. Together I am considering y minus a as the term, I am writing it as minus x by y dash. This value is substituted in equation 1. So x square plus entirely y minus a will be replaced by this. So minus x by y dash the whole square equal to 9. If I simplify further, x square minus whole square is positive, x square by y dash square equal to 9. And further the LCM, if you take x square y dash square plus x square and y dash square, I am sending to the right hand side simultaneously. So this is the equation you will get. Further y dash square is there here, so I will take y dash square common. So x square, this minus 9 comes to the left hand side, plus x square equal to 0. So this is the required differential equation. So simplification is matters, like according to the given answer we can convert. If you can check the NCERT answers, maybe it will be having this way. So yeah, either if you approach till here is also, it is absolutely right. Let's move to the further question. Question number 11. This question I have discussed already in the introduction part of exercise 9.3. Let us do once again. Which of the following differential equation has y is equal to c1 e power x plus c2 e power minus x as the general solution? So we have learnt in this one, whenever curve is given, how do we get the differential equation? To get a differential equation, we need to remove the arbitrary constants. How many arbitrary constants are there? 2. C1 and C2 are 2 arbitrary constants. So we need to differentiate the given equation twice. So first, when we do the differentiation, y dash is equal to C1 into e power x, differentiation is e power x. C1 is arbitrary constant. Okay. We need not to apply the product rule here. Fine. Next, plus C2 into e power minus x, differentiation is minus e power minus x. Again, one more time, when you do the differentiation, y double dash is equal to c1 into e power x plus c2 into e power minus x, differentiation is again minus e power minus x. So minus of minus e power x minus x is plus e power minus x. So can you see here directly, this is nothing but y itself. So therefore, what is the differential equation? Y double dash minus y equal to 0, which is present here. Y double dash is nothing but d square y by dx square minus y equal to 0. So option B is the correct. Next, question number 12. Which of the following differential equation has y equal to x as one of the particular solution? So can you see here particular solution? What is a particular solution? Which is obtained from the general solution where arbitrary constant won't be present. Fixed constants only present. Y equal to x is one of the particular solution, it says. So how do we say that y equal to x as one of the particular solution for the given differential equations? Just since in all the cases, all options, y double dash is present, d square y by dx square. So for the given curve, find out the differentiation twice. So y dash is 1, y double dash is 0. Now these three you substitute in each and every equation, whichever it is satisfying LHS is equal to RHS, that will be the differential equation. Okay. So first let us go with option A. Y double dash is y double dash minus x square y dash plus xy equal to x or not, let us check. So I am considering LHS part. So y double dash is 0. Minus x square into y dash is 1 plus x into y is x. So minus x square plus x square, which is equal to 0. So the right hand side is x is there, which is not correct, right? But here, can you see the same LHS part is there? The right hand side we got it as 0. So option C will be the right. Similarly, if I check the option B also, 0 plus x into y dash is 1 plus x into x, which is, x into y, no? X into x, which is x square. Is it equal to x? No, it is not equal to x. So option B won't be correct. Even the last option D is also not correct. So option C is the right answer. So hence, with this one, we can conclude the exercise. We have finished the exercise 9.3 also. Let's move on to the next exercise in the next video. Thank you for watching.